we're going to be solving linear equations. Now, these are equations that contain a mixture of numbers and an unknown to the power of 1. So there's no squared or cubed in here. We're just doing a standard linear equation with one unknown and some numbers. Now, the way we approach this is to group all the terms containing the unknown, for example, x on one side of the equation. We group all the terms containing the numbers on the other side of the equation, and then simplify both sides to solve the equation. Here's a simple example. We have 2 open brackets, 5x minus 4 close brackets, equals 3 open brackets, 6 minus x close brackets. The first thing we need to do is just follow the standard BIDMAS process or BODMAS process. We deal with the brackets and multiply those out. And that gives us 10x minus 8 equals 18 minus 3x, multiplying everything on the left inside the bracket by 2, multiplying everything on the right inside the bracket by 3. So next I'm going to add 3x to both sides. So 10x plus 3x minus 8 now on the left equals 18, because minus 3x plus 3x, those two cancel out, and leaves us with just 18 on the right hand side. Next I'm going to do the same with the numbers. I'm going to add 8 to both sides. So 10x plus 3x equals 18 plus 8. So that gets rid of my minus 8 on the left-hand side because we've added 8 to that, leaving 0 in terms of numbers, and we're adding 8 to the right-hand side. Then we simplify. So 10x plus 3x is 13x, and 18 plus 8 is 26. Now we divide both sides by 13. So that means that x equals 26 divided by 13, which equals 2. One more example. 3 open brackets x plus 12 close brackets equals minus 5 in brackets multiplied by 4 plus x. Again, we're going to multiply those out. So 3x plus 12 with the x plus 12 in brackets becomes 3x plus 36 equals minus 5 times the 4 is minus 20, minus 5 times the x is minus 5x, giving us 3x plus 36 equals minus 20 minus 5x. This time I'm going to add 5x to both sides. That becomes 3x plus 5x plus 36 equals minus 20, and that minus 5x has gone because we've added on 5x. Now we're going to subtract 36 from both sides because I want all the numbers on the other side of the equation, the opposite side of the equation, to be x's. So I've subtracted 36 from the left-hand side, which leaves just 3x plus 5x, and I've put that onto the right-hand side, so we now have minus 20 minus 36. We simplify, so 3x plus 5x is 8x, and minus 20 minus 36 is minus 56. Now again, we're going to divide both sides by the number applied to that x, by the factor or the coefficient next to the x. So x equals minus 56 divided by 8, which equals minus 7. But sometimes we're going to have more than one unknown. So how do we deal with those? Well, we're going to look at solving those issues with simultaneous equations. So simultaneous equations contain numbers and multiple unknowns. But to solve them, we need as many different equations as there are different unknowns. So for example, if we have x and y unknowns, we need at least 2 different equations to solve those. We do a number of processes. We perform what's called operations to those different equations. We can add or subtract whole equations to others. We can multiply or divide a whole equation to change it. And again, we have to do everything to both sides. Or we can substitute one equation into another. Here are 2 simultaneous equations that we're going to use. You can see both x and y in them, and some numbers. I've got equation 1 which is 3x plus y equals 8. I've put the number 1 in brackets to signify that's equation 1. And we've got equation 2, which is 2x minus y equals 7. Now, handily here, we have a plus y and a minus y, and that means that we can do something called solving by elimination by adding the two equations together. So I'm going to do equation 1 plus equation 2. So here I've got 3x plus y plus 2x minus y equals 8 plus 7. So I've added all the letter sides of the equation to all the number together, and I've added the number sides of the equation together as well. Now, I've got a plus y and a minus y, so those cancel out, those disappear. So I can simplify that down to 3x plus 2x equals 8 plus 7. I can simplify that again, and that's going to give me 5x equals 15. In this case, I've labelled it equation 3. I'm going to divide equation 3 by 5. So again, I'm going to have to do that to both sides. I have to divide 5x by 5 and 15x by 5, and that gives me x equals 15 over 5, or x equals 3. So now I have a value for x, but I still don't have a value for y. So I need to go back and I need to substitute x into the first equation. To be honest, it doesn't matter which you use. I'm going to use equation 1 this time because y is positive there, otherwise I'd have to do some strange rearranging. So here I'm going to put 3 back into x. So now rather than having 3x plus y equals 8, I've got 3 times 3 plus y equals 8. Take that down. 9 plus y equals 8. So I subtract 9 from both sides, giving me y equals 8 minus 9, which equals minus 1. And that gives me the value for y. So now I can say at the end of my my solving that x equals 3 and my y equals minus 1. And it is always nice to put that at the end so that anyone who's marking it can see it, and so that when you need to use that information, you know where that information is and it's nice and clear. Here are 2 more simultaneous equations. Again, we've got x's and y's on the left, and we've got numbers on the right. Equation 1 is 2x plus 5y equals 9. And equation 2 is 6x plus 7y equals 21. Now this time, we don't have the same number of x's or y's. We can't do any kind of additional subtraction on that. Not yet, at any rate. What I'm going to do is I'm going to multiply equation 1 by 3. I'm going to multiply everything in 2x plus 5y equals 9 by 3. That's going to give me 6x plus 15y equals 27. And I've labelled that equation 3. Now, I do have the same number of x's that I can use. So in equation 2, I've got 6 x's. In equation 3, I've got 6 x's. So now, I'm going to take away equation 2 from equation 3. So I've got 6x plus 15y all in brackets minus 6x plus 7y equals 27 minus 21. Again, with this, always be careful of those negative signs. So when I multiply that out, I've got 6x plus 15y minus 6x minus 7y equals 27 minus 21. The 6x minus the 6x disappears. 15y minus 7y is 8y. And 27 minus 21 is going to give me 6. So I've got 8y equals 6. So y equals 6 over 8, or 3 over 4, which is also 0.75. I don't mind if you're going to use the fraction or if you're going to use the decimal. If you're going to go on and use it in algebra, sometimes it's easier to use the fraction, but either one will work. Again, now we need to go back and we need to substitute in our value for y into the first equation. So if 2x plus 5y equals 9, 2x plus 5 times 3 over 4 is 9. I've done it in fraction form, so 2x plus 15 over 4 is 9. I'm going to take 15 over 4 from both sides. I've developed the fraction here, so I've turned 9 into 36 over 4 minus 15 over 4. And that equals 21 over 4. But that is still only 2x. 2x equals 21 over 4. I have to divide both sides by 2 to get the value of x. So x equals 21 divided by 2 times 4, which is 21 over 8, or 2.625. Another type of equation we'll look at this week is a quadratic equation. Now, we've already explored quadratic expressions. Those are expressions in the form ax squared plus bx plus c. If we add an equals 0 onto that, so the form is ax squared plus bx plus c equals 0, that is a quadratic equation. Now, you might hear people, including me, sometimes mixing up the terms expression and equation. I'm sorry if that happens, but if it has an equal sign and there's something on the other side, that's an equation. So obviously this could be written slightly differently. It could be something like ax squared plus bx equals minus c, and we would have to move the minus c to the left-hand side by adding c to both sides. But if we can write it ax squared plus bx plus c equals 0, that's a quadratic equation. Obviously, a, b, and c could be any number in this scenario. To be a quadratic equation, a must be, cannot be 0, but b or c could be 0, but it has to have an x squared there multiplied by something, 1 or something else, to be a quadratic equation. We've solved those just as with the linear equations by finding the value of x. But the important thing to remember is that quadratic equations have 2 solutions. So we call these the roots. The reason being, of course, if we root x squared, we can get back to x. So x times x would be x squared. But of course, we also have minus x times minus x equals x. So, for example, here we have at the bottom 16. We can get to that by multiplying 4 by 4, but we could also get to it by multiplying minus 4 by minus 4. So when we write root 16, the third, we can say that that equals plus or minus 4, which we write like this.